or sorry, if I wanted more than 13, then I want the probability that exactly 14 people or the probability that exactly 15 people recognize the brand. Well, to find the probability that exactly 14 out of the 15 recognize the brand, if I wanted to find the probability of 14, we're going to do the binomial PDF. What is N? What is my sample size? Okay, 15 people. What was the probability of success? It was 0.95, wasn't it? I think on 30. 95% recognized it, yes. So the probability of success was 0.95. What would X be? That's the 14 that I'm looking for. And what do we get? Okay, it should be this number right here. Okay, that 0.365756. So that's the probability of exactly 14. Now find the probability of exactly 15. Is everybody finding it? Now, as you're doing it, because I wanted to know what the sum is, what the probability of is being more than 13, so the probability of exactly 14 plus the probability of exactly 15, because it's 14 or 15, and statistically, or is going to add those. So if you just put it as one big problem, the probability of exactly 14 plus the probability of exactly 15, you're going to get that 0.829 that we said we had. And again, this is a probability, so you round it to 3 decimals. 3 significant digits, I should say. 0.829. That's the sum of the two. The probability exactly 15 would be the 0.463. But if you added those two numbers together, you're getting the 0.829. Questions? Now, one of the problems that I assigned to you guys was number 13. And it was finding the probability when guessing answers. Multiple choice questions on the SAT test each have 5 possible answers, one of which is correct. Assume you guess the answers to 3 such questions. On part A, you're supposed to use the multiplication rule to find the probability that the first 2 guesses are wrong and the third is correct. So that's the probability of wrong, wrong, correct. Well, if you did that, if you took the probability you were wrong, that was 4/5, times the probability the second one wrong was 4/5, times the probability the third one was correct is 1/5, you should have had on part A 0.128. Well, then when you go to part B, it's asking, beginning with wrong, wrong, correct, make a complete list of different possible arrangements of 2 wrong answers and 1 correct answer. So if you were doing, oops, I was on the right page. If we were doing that, we've already done wrong, wrong, correct. We could have done correct, wrong, wrong, or we could do wrong, correct, wrong. So we have 3 different ways we could arrange that. I already lost my number that I was trying to remember. The probability that we had, that first one was 0.128. That we can have wrong, wrong, correct. Well, how could probability of getting correct, wrong, wrong would also be what? And wrong, correct, wrong would also be 0.128. Well, what's the probability that I get exactly 1 wrong, or exactly 1 correct answer? So what's the probability I get this, or this, or this? What would I do? Good. Not multiply, because it's or. This is where you're going to add them. So if I get this one, or this one, or this one, I'm going to add those. So if I add those, what do you guys get? 0.384? Now, if I wanted to find the probability that I get exactly 1 correct answer out of the 3? What is the probability that I would get exactly 1 correct answer? If I did, is this a binomial distribution? Let me ask it that way. Fixed number of trials, only have 2 answers. Each answer is independent of each other, fits all of the things for being that binomial distribution. Well, if I want the probability of exactly 1, I can use my calculator then and do my binomial PDF. What will I put in for n? 3 questions. What's the probability of getting 1 correct? No? No? For 1 question, what's the probability I answer it right? 1/5. And how many correct answers am I looking for? And so if you put that into your calculator, what do you get as a probability of getting exactly 1 correct? Should be getting 0.384. Because it's 2 different ways to get to the same place. And that's what this binomial PDF is really looking at. If you're looking at finding the probability of it getting exactly that many, it's looking at what is the probability that it can happen in a certain order, and then we have to look at all those different ways of ordering these. Doing it for 3 questions, not so bad. But if you were talking about the SAT test, and I don't even know how many questions are on the SAT, but a whole lot more than 3, and then finding the probability that I get exactly, if we had 30 questions, and I know there's more than 30 questions on the SAT. If there are 30 questions, to find the probability I get exactly 18 of those correct, and looking at all the different ways I could get 18 right, that would be a long process. And so this is a much easier way of looking at doing the same kind of things. All right, so this is where you guys can start using the calculators, and I'm going to give you some more homework from section 5.3, because I didn't give you a lot of the word problems that you really had to read through things and do a lot more of the thinking through those. So tonight's homework will have both sections 5.3 and 5.4, but on 5.3, use the calculator. The binomial PDF makes things much faster and easier to do. All right, section 5.4 then. Looking at the mean, variance, and standard deviation for the binomial distributions. We've already looked at the formulas for finding the probability distribution for a discrete probability distribution. These formulas then will produce the mean, standard deviation, and variance for any probability distribution. The difficult part of these formulas is you have to have the probability of x values for the random variables in the distribution. You have to know all of them. And this was the formulas we've done earlier. This was section 5.2, I believe. When we were looking for those probability distributions for any values. And this is what we were just doing with the deal or no deal problem. At least that time, the probability of any of those suitcases was equal chances. And so we could find the probability that X happened. And we could find X times, how much each case was worth times the probability of getting that case. And adding each of those up. Well, if for some reason they had different cases that had more chances of being selected, and each probability was different, that becomes a lot more challenging. Or different times when you're looking at, if we're talking about colors of cars, I guess cars can't be doing it. Colors can't be doing it. But if we're looking at some sort of situation where we could have different probabilities, different values having different chances of being selected, you have to know every single one of those to be able to multiply by those values. And then we could do the standard deviation or variance and the standard deviation, and this was the shortcut for being able to do that. So we've looked at that back in section in 5.2. Well, if we look in 5.3, the binomial probability distribution results from a procedure that meets all of the following requirements. The procedure has a fixed number of trials. The trials are each independent, meaning that once by picking one value, it doesn't change those probabilities of everything else. Each trial must have all outcomes classified into 2 categories, commonly referred to as success and failure. And keep in mind, binomial, bi means bicycle, has 2 wheels, binomial, 2 options. It's either success or it's failure. And so when you have just the 2 options, it's better than just being a probability distribution. That binomial probability distribution is giving us even makes it a little easier to work through things. The probability of a success remains the same in all the trials. If we meet all of these, then finding the mean, variance, and standard deviation are much easier to do. Because if we're going to find the mean, then all we have to do is multiply n, being the number that are in that population, that sample, times the probability of success. Which if you're looking for, if we're talking about in the classroom, finding the probability that we're looking for a male in the classroom, then finding that probability, it's staying consistent as you do things, of being, I guess in this case we're looking at 4 out of 8 today. So having that probability of being male is 1/2 times the number of people in the classroom of 8 people means you've got 4 possibilities. The mean number in this would be 4. So it's kind of fitting into what your common sense would sort of fit into what it thinks it should be. Finding your variance, you're just taking the number in the sample, probability of success times the probability of failure. Anytime you know the variance, it's very easy to get the standard deviation by finding the square root. And don't forget, when you're finding standard deviation, you're looking at the square root. Questions there? The obvious advantage to the formula for the mean, standard deviation, variance of a binomial distribution is that you don't need the values in the distribution table. All you need to know is the number in the sample, probability of success, and the probability of failure. Since n will always be an integer, the number in the sample is always an integer, you're going to round the mean, standard deviation, variance to 1 decimal. Because it's 1 more than what the original data had, and our original data was talking about being an integer. Well, if we're trying to find what that means then, our usual values are within 2 standard deviations of the mean. So our usual values are going to be the mean plus the 2 standard deviations and the mean minus the 2 standard deviations. So that usual value still fitting in those 2 standard deviations. So if we look at number 12 on page 232. So number 12, are 24% of M&Ms blue? Mars Incorporated claims that 24% of its M&M plain candies are blue. A sample of 100 M&Ms is randomly selected. Find the mean and standard deviation for the numbers of blue M&Ms in such groups of 100. So first of all, what is the mean for the number of blue M&Ms? What is n? How many M&Ms are in my sample? What's the probability of success? So 100 times 0.24 means my mean is 24. Out of a set of 100 M&Ms, I anticipate 24 of them will be blue. How about my standard deviation? So we're taking the square root of NPQ, where we said n is 100, p is 0.24. What is q? Q is the chances of failure, so 0.76. So if you multiply those together and take the square root of it, .27. Rounding rule would take it to where? Rounding rule will take it to 4.3 because you're rounding it to 1 more decimal than the original data, which is a whole number. So now, that's my mean and standard deviation. On part B, data set 18 in appendix B consists of a random sample of 100 M&Ms in which 27 are blue. Is this result unusual? And does it seem that the claimed rate of 24% is wrong? What would be my usual range? Since 27 is above it, what's my usual maximum? Okay, 24 plus 2 of my standard deviation, so 24 plus 8.6 is 32.6 would be my usual max. My usual min would be 24 minus 2 of those standard deviations. Thank you. So I'm anticipating between 15.4 and 32.6 M&Ms being blue out of a set of 100. So is 27 usual? Yeah, it's in that range. So does that try to say that their claim at 24% is wrong? No. It's perfectly fine. Just because they claim that there's 24% of them are blue doesn't mean every package is going to have exactly 24% of them blue. But if you took a whole lot of packages and combined them together and kind of considered looking at those, we would expect it to be close to 24%. Okay? Now, for Science Olympiad a few years ago, I counted 79 blue out of 623 M&Ms in a bag. Is that usual? Now, can I just use my range of expecting 15.4 to 32.6? No. So now I have to look at having 79 blue out of 623. So what do I need to do first? I got to find my mean and my standard deviation to figure out what my usual values are. So go ahead and find, still sticking with them claiming 24% is their claim. Find my mean and my standard deviation. Should be getting a mean of 149.5 and a standard deviation of 10.7. So then that's telling me my usual values. Actually, do I care about my usual minimum or my usual maximum this time? Which one do I care about? Minimum's what I'm worrying about. And so I'm going to take and find that 149.5 minus 2 of my standard deviations. So what is the usual minimum? Okay, 128.2 is what I wrote down. So is this usual? No. So this one would not be a usual value because this is definitely well below that minimum of 128 that I would expect. If I did the usual maximum was 170.8. So for 623 candies, I would expect between 128.2 and 170.8 of those to be blue. Are we good? Okay. Questions there? But let me go ahead and give you guys your homework, and then I've got a couple problems that I'm wanting to kind of look over as part of the review. Was there anybody that was not here last time that did not get the extended problems? It's part of it. So were you here? The extended problem and the project's the same thing, yeah. Two different names for the same thing. So is there anybody that didn't get an extended problem, which is the same as a project? Okay, your review is at the top of the page. Your extended problem's at the bottom. So that's what I'm wanting to have on Wednesday. You guys' test is Wednesday. Testing a lot of people this week. So if you're having questions on those, make sure you ask. Because remember, the extended problems do come out to be an equivalent to one test score. And, yeah. You have not, you guys, I still need to grade your guys' extended problems. Those were the graphs. I hope so. Good bad ones. All right. We may have some examples for next semester is what you're saying.
Like they had numbers on their bars, but like they didn't correspond. They didn't make sense. Their bars are just
Okay. I haven't had a chance to look at those. Sounds like this one will be an interesting one. Okay, page 242 is the ones I have for being able to use as kind of a review. I need to add a page to this. Okay. Friday we'll start chapter 6, so there won't be anything due Friday. Okay, if we look at number 8, I think is the first one I want to look at. Yeah, number 8 on page 242. Reasons for being fired. Inability to get along with others is the reason cited in 17% of worker firings. Concerned about her company's working conditions, the personnel manager at the Boston Finance Company plans to investigate the 5 employee firings that occurred over the past year. Assuming that the 17% rate applies, find the probability that at least 4 of those 5 employees were fired because of an inability to get along with others. So if I'm wanting to find the probability that at least 4 of them, what am I looking for? There's 5 employees that were fired. I want the probability at least 4 of them were. What was that? Okay, there's the 4 and 5. Is this a binomial distribution? Do I only have 2 options? Yeah, it's either I was fired because I didn't get along with people or I was fired for some other reason. So it's either I didn't get along well or not. One of those two is the only options. So this is a binomial distribution. I want the probability of exactly 4 were fired plus the probability that exactly 5 were fired. So go ahead and use your calculators and find those. And we said this one is a binomial distribution. So you're going to use that binomial PDF form. This is the binomial probability distribution function is what that stands for. Remember, this does go NPX is the order you're putting those in. Does that look like what the number you're getting? Oh, I just did it as one big happy fraction or happy problem, so I didn't have to add them together. Oh, really? Yeah. Okay.
I don't know about that being right or not, but as soon as I plug it in, I don't want it to work.
I don't know. Let me do it. Don't just hit plus between them. Don't hit enter. So what I did is I had my binomial PDF that I put in, pasted it, hit plus, did the next one, pasted it, and hit enter. It gives you the answer. So hit the plus in between. So don't hit enter, hit the plus. I think that was what the difference was. All right, so everybody getting this. Now, the next part of the question, and this one should be to 3 significant digits. So that's why those 2 zeros in the front were not significant. That's why I've got the 0.00361. And then if we look at the next part of the question, if the personnel manager actually does find that at least 4 of the firings were due to an inability to get along with others, does this company appear to be very different from other typical companies? Well, what kind of probability am I getting? 0.00361. Is that usual? It is way under 5%. So is that normal? No. They've got an issue with somebody not getting along well with others and probably being the one that stirs up a lot of the problems. Because this is definitely far from being significantly under that 5%. That is that number that is always your usual. Anytime you're talking about probability, your 5% is what that is, that usual. Mm-hmm. This one is definitely different. Yeah, and that's the same. That's 2 standard deviations. It's the same as that 5%. Number 9. There's another one I was going to look at, but I'm running low on time, so we'll just really fly through it. The Brooklyn District Attorney's Office analyzed the leading digits of check amounts in order to identify fraud. The leading digit of 1 is expected to occur 30.1% of the time, according to Benford's law that applies in this case. Among 784 checks issued by a suspect company, there were none with amounts that had a leading digit of 1. For randomly selected checks, there is a 30.1% that the leading digit of the check amount is 1. What's the expected number of checks that should have a leading digit of 1? How would I find it? Okay, that's 784 times that 30.1%, so you would expect 236 of them to have a leading digit of 1. Assume that groups of 784 checks are randomly selected. Find the mean and standard deviation for the number of checks with amounts having a leading digit of 1. Well, your mean is just your n times p, which is still the 236. Standard deviation, square root of n, p, and q, is 12.8. And then just finding the expected values, so your 2 above and 2 below your standard deviations. And then the last part, given that there was none of them, since our usual range would be 210 to 261, Since there was none of them, that definitely suggests that there was probably some counterfeiting going on there. Okay. Study for your test. Test is Wednesday. No, I've got other tests I'm giving Friday. I don't need more things to grade at the same time. Yeah. I'm glad you're reminding me.